Hello all, welcome back. As you can see here, I've got the backplane that we designed. A few changes that I made from the end of the PC board design for the backplane is I added a couple of extra holes here in the middle. That way it gives it just a little extra support when I'm putting in cards in the middle section here. And then I also went ahead and just added this space for the switch over here. That way I could just turn it on and off. And I also removed some of these capacitors. I thought that was a little overkill. As a matter of fact, when I do this today, I'm not even going to put these in there because the three boards that I have capacitors of their own in there. So, and then the last thing I did is just for housekeeping is I labeled all of my inputs and outputs. So that way we've got all the bus labeled on there. So that's the design change I made from that video. If you want to go back and look at that video, it's up here in the corner. So take a look. All right, so let's get started. And first thing we want to do is start out with a hot soldering iron and make sure that it's clean. And if it's not clean, just add just a little bit of solder and clean that tip up just so that it conducts that heat really well and also doesn't leave any foreign residue in your solder, which could cause problems down the road. And then when you're soldering a board, you want to start with the lowest component and work your way up. So lowest component is going to be this resistor. It's a 1K resistor for the board mounted LED. So I'm just going to bend this around here and get this to where it's going to fit into the hole. And then I'm going to go ahead and slide it into the hole. Now you'll notice that there's room for another resistor on here. And I'm going to make some changes to this board as we're going through it. I'm not going to put in the pins for the LED or this resistor for the LED because we've got an LED on the board and I'm not planning on putting this into a case at this point. If I was going to put it in a case and needed a wire to go to the case for an LED, I would put those two components in there, but I'm not going to do that now. So I've got my 1K resistor in here, and then I'm just going to bend over the legs just a bit, just enough to hold it in place. You see there, it's not tight, but it's definitely held in place. It's not going to fall out when I turn it over. And now we'll get the soldering iron and we'll get to work. And so as we go through this, I will be doing some of this in time lapse because I'm sure everybody doesn't want to sit here and watch me. Oops, having a hard time seeing past my microphone. There we go. And not everybody wants to sit there and watch me just solder 40 pins at a time. And so there's our resistor. And we'll take our snips and just cut those legs off. So the other night I recorded this video and I was having the same problem that I'm having now, which is the microphone's in the way. I've got it fixed now, so it's a lot easier, but it was worse in the way, and so I pushed it out of the way, and it went right about there. And so I recorded the entire video with the microphone right there, and I never stopped to take a look. So move the solder over there. Okay, the next thing we'll do these capacitors, the decoupling capacitors, and we've got one there and one here. And the reason why we have two is we've got one before the LM7805 and then one after. So one for the 12 volts or the 7 to 12 volts and one for the 5 volts. And so again, I'm just going to go ahead and bend those out, turn it over, and then just hit those with a bit of solder. And then again, snip, snip. Made something totally different in this context. All right, next up, I guess, would be probably the LED itself. So we want to make sure that we get get it in the right polarity. So if the pin here is longer, is the positive, and then this side over here is flat, which is the negative. So we'll stick that in there. And we'll go ahead and bend this. And then actually over on this side, I'm going to go ahead and just bend it down. I know that's frowned upon by the LED manufacturers and probably the any board manufacturers, but I forgot to bend it before I soldered it. So we'll go from there. All right, next is probably, oh, let's do these 2 pins for the switch. And now the switch isn't needed because I've got this switch which is going to go in there, but I could just put a piece of wire and just jumper it. As a matter of fact, you know what? I am going to do that. I've got some of these legs over here, and I'm going to go ahead and just, again, this is spontaneous computer development. All right, let's go ahead and jumper this. There we go. And then we will hit that with the solder. There we go. Yep, right there. All right. Next up, and we don't need those anymore, so we'll set that over there. Next up, let's go ahead and do this 470 capacitor. And again, we want to make sure we get the polarity correct. Bend that out. Come on. And then we're going to put in some of these. I was wrong on that. Oh well. We're going to put in some of these 40 pin headers. I'm only going to put 3 in now. We've got 3 boards right now, so I'm just, in interest of time, I'm going to go ahead and put these 3 in there. Then I'm going to hold it there, turn them over. Oops, that one fell out. Okay. All right, I've done this so many times. You know what? I know what my problem is. My problem is I am not wearing my glasses, and I am too old to do this stuff with no glasses. All right, there we go. That is much better. Now, let's see if we can get these tacked on. All right, well, I did mess up. See, that's why you don't put on the taller stuff first, because when you put this in here, you can see how much taller that is. Let's see here. Yeah. And so that causes the board to stand up and parts to fall out. So what I'm going to do is I'm going to, again, improvise just a bit and grab this little tin of, or not, it's not tin, it's a little plastic case of transistors. Put these into the board. Turn it up like that. There. I'm going to try to align these the best I can while holding it down. And then I'm just going to tack one of these pins just a little bit, not even a lot, just a little bit of solder, just enough to hold it. All right, so those are tacked in there, and I will go ahead and reset that in there. I'm doing this the hard way, so learn from my mistakes. That's what this is all about. Now those are fairly straight, so I'm going to go ahead and tack the other side, and they're still straight. Awesome. So now I can move this out of the way, and I can start my time-lapse video of me soldering 120 pins. So enjoy this, and I'll be right back. All right, so there we have it. And then we'll get to the next part here. So we've got, let's go ahead and do the plug itself. All right. So that's pretty much our breadboard, or our backboard, not our breadboard. So we've got our 3 slots, our power in, our 12 volt 470 capacitor, our on-off switch. The switch on board is actually shorted, so we're good there. We've got the capacitor for 12 volts, we've got the capacitor for 5 volts, got the LED resistor and the LED, and then we get the 3 set of pins. So the next thing we want to do is put on our heat sink right here on the LM30 or 7805. That way it does not overheat. So I'm going to grab some of this compound, and I'm going to grab a screw, a nut and a bolt to hold that on. So what I'm going to do here, I'm going to go ahead and, it's easier if I put it on the back here, believe it or not. Put a little bit of this goo on here. And that's just to ensure that it makes a really good connection to the heat sink. That way the heat can transfer as optimally as possible. There we go. Set that in there. Pull that up. Give it a good turn. There we go. Now, let's plug 12 volts in there. There we go. We've got our light. Now no light. There we go. All right. So that is the backplane. All right. So now we've got the CPU board, and we're going to go ahead and start building that up. And of course, we'll start with the resistors again. So I will go ahead and bend all those down. If I don't. All right, and there we've got the resistors. Next, we'll take care of the capacitors. And we've got a couple of different capacitors on here. So we've got a lot of the decoupling capacitors for the chips and the clock timer. And then we've also got some capacitors that inform how fast the clock, I'm sorry, not the clock, but the reset should go, or the slow clock should go. So we'll take care of all of those right here. All right, the next thing that we want to do is probably the pins down here. So I'll go ahead and get that tacked on, and then make sure it's straight, and then we'll get it all 40 pins soldered up. Yep, looks good. There we go. Okay, now I got that. Let's do some LEDs. Okay, so let's do the clock as red. We'll do the reset as red. Now, if I was going to put this in a case, I just put pins in there. That way I could pull them out to a case, you know, put them on a display case or there, somewhere in there. For weight, we'll do yellow. And halt, we'll just do green, just to have a different indication. All right, next up, probably going to be the chip holders. I'll go ahead and do those. Okay, so we want to add these chip. Hello. Do I have a bent pin? Oh, I have a bent pin. Almost as bad as a floating pin. And remember, a floating pin is never a good thing. So, we've got these chip holders here, and I need something for the clock, because I don't just want to solder in a clock. I can do a what do I got here? 6 megahertz clock. I've got a 1 megahertz clock. I've got a 10 megahertz clock floating around here somewhere. So I don't really want to solder it in because I might want to change it out. So what I've got is I've got this 8-pin. Make sure it's on the camera. There we go. I've got this 8-pin chip holder, and what I'm going to do is I'm just going to take and I'm going to push up on all of these pins just a bit. Now I'm not cutting these, even though I'm using my cutters. My needle nose pliers don't close enough to really grip this well. Oh shoot, I just cut it. Okay, and then just pushing it up a bit. There we go. There we are. Just enough so that I can then grab these pins, and you'll notice that they just come right out here. So I'll go ahead and take these middle 2 pins out on both sides. And what I'm left with is a chip holder that actually holds the clock. So that's what I'll use. That way I can switch out the clock anytime I need to. Put that over there. All right, and then I'll put this in here. There we go. Now I want to turn all this over and hopefully not lose all of these. I'm usually pretty successful doing this, and to be honest, I have no idea how, because I need some of that crap. I need some of that putty that holds everything in place. So I'll tell you what I'm going to do. I'm going to start with these two, and then I'm going to graduate to having the other two. So that way we don't damage any of these pins like I seem to be doing already. Yeah, let me fix those pins. That's not really something you want to do. So don't follow my example. That's do what I say, not what I do. There we go. So now I've got these two in there, and I'll set those two aside, and we'll do that later. And I can actually hold those in place just in the back here, just by holding on to the pins that are extruding. And there we go. Now we've got those in there. So I'll throw some solder on there, and then we'll go from there. The other thing that I want to mention while I'm doing this, for those of you who don't normally solder or don't normally solder on PCBs, I think one of the misnomers about soldering is that you're soldering the contact to the pad. And you're soldering the pin to the pad. And the interesting thing is that these pads are actually metal plated all the way through and go all the way through to the other side. And so if you notice here on these resistors, let me make sure I'm on the frame here. Yep. Notice on these resistors, there's solder coming out the other side. And that's actually very desirable because A, it strengthens the bond, but it also strengthens the electrical current going through. I mean, the tin and the metals that are in the solder don't conduct as well as, let's say, aluminum or copper, but they do still connect. And so the more that you have in there, the less chance you have of getting a cold solder joint. So you don't want to be skimpy with your solder. You want to definitely make sure that you're soldering with enough solder. But you also don't want to overdo it, because then you get bridges between the pins, and you don't want that to happen, because that will definitely cause an issue. So actually, you know what? I'm going to do the clock one first, and because that's only 4 pins and I can talk while doing that, and nobody will complain that I'm just showing a film of me. I mean, a film. Jeez, how old am I? A video of me soldering, and it's boring. So I can do these 4 pins fairly quick and get them done, and then I can fast forward through the CPU soldering. So, and there's the holder for the oscillator, and then we'll put in the chip and make sure it's facing the right way. It is. Well, the CPU holder, there it is. Grab some more solder and tack this thing in place. And the other thing that I'm doing when I'm tacking this in place is I'm pushing down on the board a little bit so that the pins are extended as far as they can go. That way we don't have a gap right here. And I'm not always successful with that, to be honest. I'm not saying that I'm the best solderer by any means. Again, no formal training. This is everything I'm doing. I've just learned by doing it and making mistakes. But some of those mistakes, you know, include making a crappy looking board because I didn't push down on the board and I left something sitting way up high. And with chip holders, it's especially evident because, you know, they're supposed to be fairly flush with the board itself. So by the way, I just recently got a solder reel dispenser. Again, not a plug, nobody's sponsoring this, but being able to just pull it off a roll rather than have the roll of solder bouncing around on the desk is just very convenient. So when you're building your bench, make sure you get something, even if you build it yourself, just like a dowel and some wire to hold it up. Just have something. I'll show you this one here. This is what this looks like. Again, I'm not, there's no advertising here. I'm just kind of giving some good advice. That way when I pull it, it just unrolls. So, yeah, there you go. All right. Now, the other thing we've got to add is this capacitor and C2, which is, this capacitor is the amount of time that it takes to reset. It controls that. And this capacitor is it controls the speed of the slow clock. And now, but one thing I want to do first is kind of measure. Yep, the capacitor is higher than the pins. I hope you can see that. Yeah, you can. So I'm actually going to put the selector between fast and slow clock in first, and then I'm going to jump over to the capacitors. So there we go there, and let's see, let's try to get those as straight as possible. Tack it. All right, check it. Yeah, it's a little crooked. Let me see if I can straighten it out a bit. There we go. And again, this is not a critical piece that has to be perfectly straight to ensure correct usage. It's more of an aesthetic thing, and I really don't like pins that are crooked. All right, so what I've got here for these capacitors is I've got fairly large capacitors. I've got 22 microfarads, both rated at 16 volts. And the reason why I did that is on the reset, I'm not, you know, again, this isn't like a high performance computer to begin with, so I'm not worried about how long it takes to reset. And then when I push the button, the reset LED will light up, and I'll get to watch it for a couple seconds while it runs. So I'm gonna go ahead and do that. But then on the slow clock, I definitely want a there's the ground. I definitely want a bigger capacitor so I can run this clock slower and debug things that are happening. I don't want to have the slow clock be super fast because it will impede testing. So let me solder these in there. Oops. There we go. All right, and I will clip these legs. By the way, just for information, this is probably something everybody does, but I'm going to go ahead and say it. I've got a magnet that I use just to come over here and pick all of these legs up when I'm done. So it's not that difficult to pick up, but since this silicone mat, it's kind of sticky. Not really sticky, but it's not slick. It's hard to pick stuff up from, especially if you don't have any fingernails. So I use a magnet to pick it all up. Let's see, reset switch I'm not going to do. All the resistors are there, all the capacitors are there. We've got the selector for the fast and slow, and I've got a where is it? I've got a jumper here somewhere that I can use to put on there, but we're not going to plug it in right now, so that's not that important, but that'll complete the board. So then all I have to do really is put in the chips, and we'll be good to go. So let's see what we want to start with. Let's start with the Z80 processor, and what I've got here is I believe it's a 10 megabit. I'm sorry, not megabit. Wrong usage. A 10 megahertz Z80 processor, so I'll plug that right in there. It would be interesting if it was a 10 megabit processor. All right, so there's that. And then I need a 556 and an HCT 14, which I will figure out where that is. I know I've got a bunch of chips sitting up here on the bench. Here is an HCT 14. Whoops. Let's put it in the right direction. And there that is. And then I've got a 556 somewhere up here on the bench. I'm in the process of having shelves built behind me so I can have all of these things neatly organized. Right now my workbench is a little disorganized. I thought I had a 556. Oh, there it is, 556. And again, face it the right way, make sure it's in there, and put it in. All right, now this is ready except for the jumper right there, which I'll have to get one out of my stash. But there is the CPU module, and that's done. And next we'll move on to the memory module, and we'll get that all soldered up. Okay, so here you can see we have all the parts we need to assemble the memory module, and I will again start with the resistor and then move to the capacitors, and then add the probably the 40 pins, and then the chip holders. So stay tuned as I do all that, and be right back. All right, so there we have the memory module, and we'll go ahead and put in the ROM chip, which I already have some programs or some program logic in it from the breadboard. And then we need a RAM chip and a couple of 688s, HCT74, HCT32, and HCT00, which I will get, and I'll plug all those in here in just a little while. But next, I want to get to our display module, because if I can get all these 3 cards done, then I can demonstrate, I can plug them all into the backplane and demonstrate whether it works or not, which I expect it to work just based on the breadboard, since the breadboard was off the same schematic. Since the breadboard is off the same schematic as these boards, but we'll see. Releasing to production is always fun and always adventurous. So let me go grab the display board, and then we'll move on with that. All right. So here we are again, back doing the LCD module. And as you can see, I've got all the parts laid out. Okay, and I'm back, and now I've got my 2 row pins. 1, 2, 3, 4, 5, 6, 7, 8. I think that's what I've got. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So let's verify that. I've got 2, 3, 4, 5, 6, 7, 8. Yes. Go ahead and of course I broke it in the wrong place because I wasn't using 2 sets of pins. 2 sets of pliers. But I know that I'm going to use 0 and 0, 1 for the output, at least to start with. So I'll just go ahead and tack that in. All right, let's see here. So and there we go. It looks good. And actually, the interesting thing is, in some of the stuff that I've been thinking about doing with this, I think E0 and E1 are going to be used for the video display. I'm going to attempt, and this is by no means a promise, so please don't hold me to this, but I'm going to attempt to do a VGA interface, and one of the I/O ports I'm going to use is the E0 and E1, so they probably won't be used anyways, although this definitely was not an instance of me being proactive and, oh, I'm not going to do this. This was an instance of me just breaking the pins wrong. So Don't think this was part of a bigger scheme. It's not. So there's my pins there, and the last thing the two last things I need to do are the transistor that actually switches the power off for the display, so we can do a true reset. Take a look at the video if you want to see how that works. And then, of course, the final part is the capacitor. And I'll go ahead and just plug that in there. Let's see, plus and minus. There we go. And this is just because the display takes a little bit more power. And rather than when it needs power to light up or to, let's say it goes from displaying nothing to displaying a bunch of characters, it needs an extra It needs an extra jolt of power. And what we would rather do is have that come out of the capacitor than come off of the bus and maybe impact other areas of the system. So that's the whole reason behind it. It's nothing nothing magical or fortuitous. That's not even the right word to use here. It's basically just a way to provide some extra power when the display needs it, since it is a fairly power hungry device compared to everything else on the board. All right, so there is our transistor and our capacitor. And as soon as I get these leads trimmed, there we go. Those look good, but I'm not confident about those transistor pads because I did not resize them. So I'm going to pull out my scope and just take a quick look at them. And yes, they are separate. They did not bleed together. So the microscope is invaluable with smaller pads like that. I don't know why I didn't resize these pads. Kind of a faux pas on my part. All right, so there is the LCD display card. All I need to do now is get a jumper, put it in 0, 0, and 0, 1, and we should be good to go. Plug everything in the backplane. So let me get everything together, and then we'll plug it all into the backplane and test it out and see if it works. All right, folks. So we've got all the cards here fully assembled. We've got the CPU, clock, reset module with all of the chips in it, the jumper on the fast clock. And so we'll go ahead and we'll insert that into the backplane. You know what? Before that, I've got these standoffs that I'm actually going to put into the backplane just so that it's not sitting directly on the bench. If there's any kind of metal residue or legs of pins and stuff like that, I really don't want it to cause any shorts, which could cause issues with how it works, or B, worse yet, short out the power supply module, which gives us definitely some issues of having to change out the LM7805 or whatever. So I'm going to go ahead and just add these legs onto it, and just like I said, just to keep it up off the surface, just a little safer. They don't have to be anything spectacular. I've got these. I've got little plastic ones that do the same thing. These just happen to be closer when I reached for them, so to be honest, that's why I'm using them. It would be interesting though to get some like 4-inch standoffs and build a multi-tier computer and just have a ribbon cable running between the two backplanes. But that's for another day. I'm really really big into the whole hardware side of it and doing interesting things. There's going to be a video coming up soon that I'm just going to have an LED panel full of you know, the address and the data bus and then all of the status indicators, mainly just because I can. So here's the backplane, and we'll get that right there. And like I said, there's the CPU card. We'll go ahead and plug that in. And the other day, I released a video about the designing the backplane, and several people had comments about using these 40-pin connectors, these headers. And this is not a final design. I would never, if I was going to like release this to the public, I would never use these. I would use a card edge connector just to give it a little more stability. This is really just for prototyping. I can easily put you know, the DuPont wires. Here's an example. I can easily put those in there and, you know, do a wait or do, you know, whatever, an interrupt. And that's really the only reason why I'm doing it. So in a future version of this backplane, you will see card edge connectors. I just, you know, between doing that and the cost of the card edge connectors, I didn't want to waste them. You know, who knows how many of these backplanes I'll have to build to get it right the first time. Wait, that didn't make any sense. Who knows how many backplanes I'll have to build to get it right. It's probably never going to be the first time. So anyways, here is the ROM and RAM module. There's the EEPROM that we have right there, the RAM chip, and then all the associated chips. I'm going to plug that right in here. And then we've got the display module right here. And actually, we're probably going to need to tweak the resistor on the brightness. That's all the way up. That would be the brightest. But I'm going to go ahead and just back it off a tad and just see what turns up. So plug that in there. All right. So there's our 3 cards. And I'm going to go ahead and grab 12 volts and plug it into our backplane here. Oh, there's a cable in the way. There we go. So we've got that plugged in. And obviously nothing happened because the switch is in the off position. But if we go ahead and turn it on, you'll see that the reset light, that wasn't what I expected. Let's turn that off and turn it back on again and see what happens. All right, so it's doing something, but it's not doing the right thing. So we'll definitely have to troubleshoot this. It looks like it's printing stuff, but I can't really see what it is. Let me change out the clock for, actually, let me just change the clock to the slow clock and see exactly what it's doing. This will give us a better indication. It'll just take a little longer. So the clock here, you can see, is pulsing. It's fairly, I think you can see it. Yep, you can see it. It's fairly slow, so it's going to take many cycles to get through the resetting the or initializing the display and then showing the Pony80 screen. And there, okay, so it cleared it. So it is working. I mean, the stuff is working. Let's see exactly what we get here. We should get a dash and then an equal sign and the words Pony80 and then an equal sign and a dash in the old DOS way of doing cool headers. So let's see. I say DOS. I really mean text-based. All right, there's the dash. And then we would expect to see, after several clock cycles, an equal sign. However, notice that the dash is showing up 3 characters in. There's the equal sign, but it's showing up 3 characters in. It should really show up at the far left, if I'm not mistaken. If not at the far left, maybe 1 character in. I don't remember if I put a space in there or not. I have to look at the code. So it is working. It's just not working correctly at full speed, or working correct even slow, because like I said, it's in the wrong place. So I think in the next video what we're going to do is we're going to hook this up to an Arduino and check out what's going on the data bus and the address bus with several other pins, and I'll hook that up. I'll write a short program. If any of you have seen Ben Eater's video series, you've already seen the basics of the program. He was doing a 6502, but with the Z80, it's going to really be the same thing. So I'll quickly put together a program to look at all of the major lines, the address, the data, the M1, IORQ, the read write, the MREC, and just see if we can tell what's going on with this, because obviously when we bring it up to speed, there is something terribly wrong. But also even on the slow speed, you notice that it's indented here, and it really shouldn't be. I think it starts on the second character, which it's starting on the fourth. So there is something wrong here, but hey, that's prototyping. Put it together, see what sticks, see what doesn't, and fix what doesn't, and move forward with what does. So until next time, I'll talk to you later.